In question letter A, we were told to find the collision time delta T COL to two significant figures. Step 1 is to find the speed at impact. The formula that we used is V is equal to square root of 2gh sub 0. And then we are going to substitute the value. J is the gravity, so its value is 9.8, and h is 2. So if you are going to calculate that, it results to the square root of 39.2. The square root of 39.2 is just equal to 6.26 meter per second. Step 2 is we are going to find the deceleration. The formula for the deceleration is v squared sub f is equal to v squared sub I plus 2ad. And then we are going to derive. So now the formula is a equals v squared over 2a. After that, we are going to substitute the value. So 1 is sir, and then if we're going to calculate that, the answer is negative 1960 meter per second squared. And then finally in the step 3, we are going to find the collision time. The formula for we are going to use this formula and we are going to derive it. The formula is from the kinematic equation. After deriving, we substitute the value and then mauna siya ang answer, sir. And mauna siya ang answer. And then to two significant figures from 0.003139 seconds, nahimo na siyang 3.2, and then imo na siyang i-times sa 10 raised to the power of negative 3 seconds, and then ma-result siya of 3.2 ms. So the question in letter B is find the N average, the magnitude of the average force exerted by the ground or the person during the collision in newtons. During the collision, two forces act on the person. First, the gravitational force mg acting downward. Second, the normal force from the ground N acting upward. The average value of this is N sub average. The person is experiencing a very large upward acceleration. Deceleration to stop. According to Newton's second law, the net force is equal to mass times acceleration. Let's define the positive direction as upward. Net force, or F sub net, is equal to N sub average minus mg. Mass, or m, is equal to 60 kilograms. Acceleration is, we calculated the constant deceleration to be a equals negative 1960 meter per second squared. But since it is upward, so the positive. Now we are going to apply Newton's second law, which is this. N sub average is equal to mg plus m, and the absolute value of A is equal to m times j plus absolute value of A. After that, we are going to substitute the value, and then after calculating, this is the answer. 1.2 times 10 raised to the power of 5n.
Good day, sir. Here are the explanation for number 3, letter C and D. So, what is the ratio of the average force of the ground of the person to the gravitational force on the person? Can we effectively ignore the gravitational force during the collision? So here are the um, here the formula for getting the gravitational force. So gravitational force is equal to the mass times gravity. So our mass is 60 while our acceleration due to gravity is 9.8. So we need to multiply this 2 and then we have a 580 Newton. So the second one is we need to find the ratio of the average time to the gravitational force. So our Newton's average is already answered by letter B, and then our gravitational force is already also answered. So our Newton's average is 118,188, while our gravitational force is 188. So we need to divide this two, and then we have a answer that approximate 201. So in letter D, 201. Since the average force is 201 times greater than the gravitational force, we can effectively ignore the gravitational force during the collision. Next, letter D. Will the person break his ankle? So, first we need to calculate the braking force or the F brake. So, F brake is equal to for a force per area times the area. So first for area is 1.6 times 10 raised to the power of 8 newtons per meter squared, while our A is 3.2 times 10 raised to the power of negative 4 meters squared. So multiplied and then cancel the meter squared. So we have a F brake that is approximately or equal to 51,200 Newton. Since Newton's average is equal to 118,188 Newton is greater than the F brake, which is 51,200 Newton, so the person will break his ankle.